Alright, let's start with our first problem here. Okay, so it's find to the nearest degree all values of theta between 0 and 360 that satisfy these two equations. Alright, now, if I were to look at this one normally, I'm thinking of it as, let's see, can I write this as 4x squared minus 2x minus 3 equals 0. And I'm saying to myself, yeah, like I can factor that. I got 2's and 4's, and you know what? It's just not going to work for me. So, I'm going to say to myself, all right, well, I might keep that on there actually, now that I think about it. Okay. I'm going to use my quadratic equation. Would this work for all of them? As long as it's second degree and everything is in terms of one function. You can't do this when it's got two functions like sine and cosine in there. As long as it's one, we're all good. Okay? So, let's see what we can do. All right? In this case, we're going to use the quadratic formula. We need our A, B's, and C's. Since it's already equal to 0, we got it all set in what format? A equals 4, E equals -2, C equals -3. All right, we use our quadratic formula. X equals -b plus minus the square root of b squared minus 4ac all over 2a. Okay, make sure that's memorized. Remember, we're letting x equal sine of theta. Okay, so makes it easier at the end when we sub this back in. Okay, plug in our pieces. Okay, -2 plus minus the square root -2 squared minus 4 times -3. Right? All over 2 times 4. Okay. Watch your signs, because that's where most common mistakes happen. -2 becomes 2, plus minus the square root of 4 minus 4 times 4 is 16 times 3, which is 48, but two negatives make a positive, so it's plus 48 all over 8. Again, keeping it with the process of simplifying it, 2 plus minus the square root of 52 all over 8. Let's see if we can find some perfect squares in it, reduce it, makes it a lot nicer. Well, if I see 4 times 13 is actually 52. So 4 times 13, the square root of that, well, we know the square root of 4 is 2, so it's 2 plus minus 2 square roots of 13 all over 8. And then that simplifies because something can be pulled out of all of these. You take a 2 out of all of them. That's a 4, a 1, and a 1. And we get cosine, or not cosine, I'm sorry, sine of theta equals 1 minus the square root of 13 over 4 and 1 plus the square root of 13 over 4. Alright? Again, we're not done. Okay? What's vital to this process is actually finding out these numbers. Okay? Watch what you do in your calculator. Alright? So using my wonderful TI-84, I will test it. Okay? I need 1 plus the square root of 13. Okay? Make sure it's all in parentheses, just like it is there. 1 plus the square root of 13, close, close. That's all divided by 4. And I get that wonderful number when I put a plus in there. There's a problem with that. The number's greater than 1. Cosine and sine lie between -1 and 1. So this one right here has no answer. Okay? No solution. Okay? So you're out. So now I got to do the other one. Alright? Cheap trick. Don't have to re-enter it. Second enter brings up the same thing, and I'm just going to move all the way back here and change the plus to a minus. Don't make it the negative, make it the minus sign. And I get that. That one is between -1 and 1, okay? So I need to now know, alright, it's negative. Alright? We need its reference angle. Well, if we do second, we're looking at sine. So I do second sine of this angle. Second answer. I get that. I get -40.64. Alright, 40.64 is our reference angle. Alright. so we can ignore the negative, okay? But there is an easy way, okay? We can start with looking at it like this. So the reference angle, and I said to the nearest degree, so we can round this answer at this point to 41 degrees. 41 degrees. Okay. Remember, this was now negative. If it's negative, where's sine negative? Sine is negative in quadrants. All students take calculus, 3 and 4. Q3, Q4. So now I've got to just do 180 plus 41, which is going to be 1 or 221, and 1, or not 180, but 360 minus 41, which is 1 or 319. Okay, those are my solutions to this thing. Okay, so make sure you be careful. Also, just to let you know, once you got this answer, if I add 360 to it, 319. Isn't that one of the answers I got? You can always get a freebie there, but we still need the reference angle up there, so be aware of that. All right, these take a little bit more time, but they are doable. Okay, so be careful on your algebra, and you'll get them always right.